Okay, hi everyone. I'm gonna try to speak in the micro. It's not that easy. See, that's better. Yep, perfect. So I'm gonna try to speak in the microphone. It's not easy, it's not a perfect height, but let's see, it will work. Okay, thanks everyone for joining. We have two sessions tonight. First of all, our session from Dashdot, which I will be presenting, and then a second one by Happy Client, Jonathan, who's there, will be presenting it. This will be, I guess, a bit more our approach, how we work as a digital product studio, more focused on the coding aspect. Jonathan, I think, will be a bit broader in terms of like the agentic organization for a startup. Yeah, perfect. So, yeah, and feel free to ask any questions. If you have a longer question, maybe keep them for the end of the presentations. I think Janus wanted to batch the Q&A session. So anyway, great, let's start. So first of all, maybe who am I and who's up here? So we're Dashdot and we're an AI native digital product studio, but we also, like every digital product studio that was born before the AI wave, have a very human adoption curve. So on the left side, we have 15-year plus experienced veterans in software engineering. On the right side, we have juniors and interns. The only thing they know is basically AI engineering, and they don't have the skills or the experience yet to evaluate whether the output is of high quality or not. So the adoption is quite difficult to manage in a team with a very diverse skill set. Let's see, slides are loading. But before I talk, we listened to what you sent in, the questions that we sent beforehand. There were a couple of topics that stood out. Like the room is very diverse as well in terms of experience and where you are with agentic coding. A lot of you mentioned I'm new to agentic coding. I use Cursor or Claude Code, but not really at an automated level yet. Building an app, how can I scale it to production? Balancing speed with quality and understanding my code base, keeping control. That was one of the top questions, I guess. And just a credible place to start. What are the foundations? Where do I start? So 3 main topics I picked out. Where do I start? How can I stay fast without losing control? And how do I scale the underlying systems? Everything tonight is grounded in one real code base. We're building a new startup. So besides building products for clients, we also build our own startups. We have one startup, WebClue, who recently raised a first seed round as well. They're at our office as well, so the team is next to ours. So we work with a lot of startups, we build startups, and we're working on a new one, and it's this code base that we will use as an example tonight. We're not gonna go into the details of what the startup does, but go into the details of how we set up the code base to go faster after the initial development. So that's the working title of the startup, Involve. We're gonna show how we're building it right now, not what the product actually is. So maybe before we start, I'm going to take you through a bit of the history of agentic engineering, let's say, of the terminology and how it came to be, and how it maps nicely on our experience as Dashdot and our engineering team. So what we went through when the entire industry was shifting towards a new paradigm. The model was never the hard part. And I guess I put a quote from Jonathan up there as well. It's a bit paraphrased, but the hard part is building the environment around it, around the model. Or as Jonathan says it, stop building the product, build the system. As a mental model, you can look at it like kind of a motherboard. So a computer, at the center you have the CPU, which is the model, but for the model to do something useful, it needs a lot of connections. You need persistence, file system, Git, progress files. You need some way of doing actions. Those are the I/O systems. You need memory. That's basically your context. And you need some system of control. That's your compaction, orchestration, loops, etc. of the model. And then last, the observation and verification, so screenshots, logs. The model needs a lot of tooling around it in order to do actual work. In that sense, the model is only 10%, I guess, of your entire system. The other 90%, let's call it the harness, is the car, but it's also the road and the traffic rules. So it's everything that keeps, that makes the engine useful, but also keeps it on track. You can frame it in a couple of layers. So the framework layer, that's where I think most of us spend our time, and what most of us are expecting of the talks tonight is orchestration logic, instructions, tools, etc. But you also have the developer interface. How do we interact with it? And then you also have the cloud infrastructure. How does it interact with the operational layer where the software is running? So how the industry and we, Dashdot, got here at this point. So I'm going to take you through a bit of the short history, I guess, the last 4 years. We started out with prompt engineering, then context engineering, then harness engineering, and where we are now, loop engineering. I guess maybe raise of hands who's getting spammed by loop stuff on Twitter, LinkedIn, whatever. Yeah, so I'm going to take you through the steps and what it meant for Dashdot. Why? Because everything built upon the last layer. So prompt engineering, 2022, basically finding the magic spell, the wording that makes everything work. It's kind of role-playing, chain of thought, pretend to be a skilled software engineer, etc. Real results, but it's a bit, Janus, do you need something? No, okay. Real results, but it's a bit brittle and you can't scale it because the context is still trapped within a single person. You can share the prompt, but you can't really share the knowledge that you inject into the prompt. I think for everybody, it meant AI was just a clever assistant, basically a copy-paste thing that gave you a result and that you copy-pasted back into another system. Up to the next step, the context engineering. Context engineering was basically the, I think it's a bit small maybe, but the curation step to figure out what do I need to put into the context window to make it deliver valuable results. So instead of me having to type words, it would automatically connect parts of the knowledge to get a better output. That was the context engineering part of it. I guess most of us started catching up with more advanced development in terms of AI when this context engineering became a thing. For us, it was a trigger. The trigger was Notion AI. When Notion AI meeting notes was first launched, so that was in the, I guess, around April of 2025, we immediately saw that we had to start recording everything. So we immediately started recording every meeting, every discussion, everything we did was getting recorded in Notion AI. Because of the overload of data, you immediately started to see, okay, I need some sort of way to manage what I'm sending to my AI agent, whether it's a coding agent or something else. That's where the entire context engineering became even more relevant and where all of the connector stuff also started to accelerate. For us, that resulted in building a company brain, which today is still in Notion. That's one of the challenges we still have. I'm getting into it a bit later. How do you connect the company brain that's in Notion, which is a human interface, with an agentic interface that has the markdown files and keep everything aligned and in sync? So step 3, harness engineering. That's fully focused around how do I build an environment for the agent, for the AI, for the model, as opposed to building the instruction. Context engineering was still building the instruction, the context that you gave the model. Harness engineering is not so much focused on the instructions, it's more focused on the environment around it. So that means tools, guardrails, continuous integration, and everything around it, review agents, specs, etc. So maybe the evolution from prompting the AI agent, please be careful, please make it 100% secure, to the CI environment just won't let you commit anything that doesn't pass all the tests. Then the latest, for us that meant that we moved to a project brain, to everything, a documentation of everything surrounding a project within the Git repository. So maybe for context, a lot of you, I guess, are startups or working on a single product, so you maybe have a couple of repositories, but it's very limited to a handful probably. For us, as a product studio, I think we have about 200 repositories currently in our GitHub account. So we need a way to get a structured product brain that's reusable across projects. And that was our biggest challenge, to being able to structure every single product in a similar way, but still have all the context within the Git repository. I'm going to get into it later, and Arno is also going to show some stuff, but we use GitHub Spec-It quite intensively. A lot of pre-commit hooks, a lot of guardrails, CI setup, and it's all connected to our project brain, sorry. And then the latest iteration, I guess, is the loop engineering part. Basically, it's a loop wrapper around your agent harness. It's allowing it to be triggered on a schedule or an external trigger, triggering a loop. And two important parts in making that work is being sure that you have set the right goal for the loop and that there's an actual test for the loop to be done. If the test is not clearly defined, your loop might run indefinitely and might never end. So loop engineering is the latest thing we got into, I guess. And we specifically today apply it for bug fixes. So we're moving towards a fully automated loop there, but it's still early days. Another loop we're working on is, because we use Spec-It quite intensively, is to have the plan build, evaluate loop fully automated so that we can fire off a new feature request with Spec-It, spec the full feature into full details, implement, and evaluate. Arno can also show the workflow that we use with GitHub Spec-It, sorry. And again, there's still quite a lot of human involvement here, but we're working towards fully automated loops. So I already mentioned it. For us specifically as a digital product studio, it's hard because we have several products at the same time. Typically we launch we work on 5 to 10 repositories every single year, sometimes even more, as opposed to working on one product. So we need to have a structure we can replicate across all of our products. That was the biggest challenge, figuring out, okay, how do we keep the fast pace, but across repositories? So what does that look like without a harness and with a harness? Without a harness, every project is a fresh start. It's basically an experiment. Quality really depends on the quality of the reviewer, so the human in the loop. Onboarding of AI in the workflow is very hard. And design can wildly vary depending on your prompt. With a harness, all those things get solved and across projects. So every single project, we know we will have the same quality when we start a new feature. So it's not a productivity trick. It's an absolute necessary part of our infrastructure to make our operations work. So the system we've built, it's 3 layers. It starts with the Claude or AgentMD file, which for us, it's more of an overview. It doesn't contain all the rules, etc. It's a guideline that guides the agent towards the correct piece of information in the rest of the repository. The layers consist of, first of all, skills and plugins. I guess everybody knows those. Context files, that's where a lot of our own, let's say, opinionated structure comes in. And then quality gate, of course. Like I mentioned, our Claude or AgentMD file, it's an entry point. So So it's not a manual. It does contain some rules, the most important ones, I guess. I can tell you more about it. Arno is, by the way, our CTO at Dashdot. I haven't mentioned that before. And he's sitting right there, so you can ask him all the difficult questions afterwards. And it guides all the AI agents towards the correct piece of information that they're looking for in the challenge they're currently solving. So it can guide them towards a spec MD file or a technical specification, a skill. It can be a lot of things. It's orientation, not documentation. Then skills and plugins in 4 categories. First of all, dependency. Quality gates, formatting, linting, code-based intelligence, testing. That's the way the agent can self-correct, can course correct because it gets feedback based on those tools, based on those parts of the harness that feeds the agent with information on what's not working and what should be updated. An important lesson here for us, I guess, is if it doesn't live in the repository, it doesn't exist. The agent is very limited in terms of context window. Every agent is quite limited these days. It will probably change in the future, but if it isn't in the repository, there's no way for it to retrieve it. You can allow MCP connections, etc., but it will make things a lot more difficult if you're working with cloud sandboxes and everything. So making sure that the information is available within the repository really helps in guiding it along the way. So that was for us the most important, let's say, switch. We changed all the documentation to be available within the repository, and we were also working on connectors to automatically feed information from Google Drive, from Notion, and convert it into Markdown that automatically updates within the repository. Otherwise, it makes your life a lot more difficult. That eventually evolved into 2 skills that we have built internally. It's a scaffold skill and an AI harness skill. Both of them have 2 functions. First of all, the create function that helps you set it up in a new repository. Scaffolding sets up the entire scaffold for a full stack TypeScript project. Auditing will audit an existing repository in terms of how we want to structure it, what is probably not according to our architectural guidelines, and what should be updated. The AI harness skill does the same for the AI harness that we use. So the create functionality will set it up in a repository, so it has everything in terms of the skills, the way we document stuff, the project brain, and the guardrails, everything. And the audit part of it does the same. It audits an existing repository in terms of, okay, what is missing for us to work with our agentic setup the way we want it to work. Sorry. Maybe in terms of agentic engineering, it is a spectrum. I'm not sure who considers themselves on the left-hand side of the spectrum. So fully vibe coded, less structure, more speed, code is disposable. Of course, Sebastian, he's our head of design. Agentic engineering, on the other hand, it's focused on structure, reliability, and that's where formal specs, architectural documents, automated evals, everything we've been discussing, and I guess what most of you are looking for, that's where that comes in. And most of it is actually classical best practice engineering stuff, but wrapped in an AI layer, wrapped in an agentic setup. I'm going to talk about it a little bit more after this slide. This is typically what you see if you have 2 more long-living projects. First of all, vibe-coded, or the first one vibe-coded better. The second one started out with an agentic engineering setup. The difference is, in an agentic engineering setup, you spend quite a lot of time setting up the platform, the systems around it, the documentation, everything that documents the way of working for whether it's a human engineer or an AI agent. The setup is a capital expense that's quite a bit higher than vibe coding. Vibe coding, go to Lovable, enter a prompt, and off you go. There's no structure, there's no systems, there's no guidance, there's basically just a prompt box, and it will output code. There is a point at which the vibe coding will start being operationally very expensive. Not sure if anybody has experienced this, but the vibe coding death trap where you just keep prompting, you're stuck, it doesn't get solved, even after hours of running an agent. So that will happen if you don't have the proper structure in place. Agentic engineering, on the other hand, you set up the systems so everything is in place to self-correct. How we currently work, so we rely heavily on spec-driven development, which is something we also see in the industry. The reliance on specs is getting a lot bigger, and specs also contain, if you do it right, the evals and the testing descriptions that you need for an agent to review the work that has been done. It's basically the AI-driven software development lifecycle. And it went from originally a sprint cycle of weeks to minutes or hours, but the bottleneck is more and more becoming getting the specification quality really, really high. And that's where we also focus on. So we focus on writing high-quality specs, which is something in a startup, I guess, was, especially initially, it would just not be done because it would be left up to the skill set or the experience of the developer to implement a feature, and the specs were an afterthought, not needed if one conversation could get the developer to implement it. That changes completely when you're working with agentic coding. You need to be aware that every agent starts with zero context. It doesn't have any idea of what you're doing. It needs to get the context all from the repository, the information that's there, collecting every piece of information in order to build out a feature or implement something. So we heavily focused on GitHub SpecKit. We're gonna give a short demo. So who knows GitHub SpecKit? Okay, not a lot of people. Who knows GStack from Gary 10? Some people. Okay, so it's a collection of skills and plugins. Let's focus on GStack first. Gary 10, the CEO of Y Combinator, I guess, he has built GStack, which is a way to develop software, but it's highly focused on mimicking, let's say, functions, human functions within a company. So he has built a code reviewer, a CEO, go-to-market, a specialist, and all of those AI functions work together to come to a specification of what should be built. SpecKit is very much engineering focused. It's focused on writing high quality, highly detailed specifications for a feature. It follows a certain paradigm that it has existed for about, I think, 15 to 20 years. And it has been used in traditional software development as well, which means that a lot of the patterns that are in there are inherently a part of the model training as well, and it works really well for us. Gonna leave the demo or the explanation of SpecKit up to you. Maybe something that is quite new, I guess, is self-improving or self-directing agents. This is a screenshot from Boris Cherny, the original creator of Claude Code. They have been using Claude Tag, which launched last week, I guess. Who knows about Claude Tag? Okay, so basically it's Claude code that lives in Slack, and you can ask it anything, and it starts off in its separate cloud environment, will write code for you, and come back to you in Slack when it's done. So Anthropic has been using it for quite a while internally, and about 65%, the number is outdated, about 65% of their code is now written that way. So by prompting Claude from Slack, from an internal messaging system, basically. So it changes the entire way of working for a developer. I think Boris even ditched his IDE a couple of months ago. He doesn't use it anymore. He doesn't look at the code anymore. So, but the thing I wanted to highlight here is that you can use it in PR reviews as well to correct its own rule sets. So then you get the self-improving system, and that's exactly what this is showing. He asked Claude to change its own rule set. And that's where things get interesting, because then it starts learning and changing stuff as you go, while you're developing your project. The thing we use quite a lot right now is to automate bug fixes. To go from a Sentry error or something else, can be post hoc an error, to a linear ticket that gets assigned to Claude, and it comes back with a pull request and a preview environment on Vercel where the bug fix is already present. I have a small video to show you. I'm not sure who uses linear and has worked with linear agents or something in the past. Some people, okay. So I'm gonna leave it here and let you do a short overview of how we set up a repository.
Right, I'll go through the layers as Maarten explained them. So, let's start here. The skills. We have included a lot of skills for the dependencies we use a lot. You can see things like BetterAuth, which we use for authentication. There's Dinero, which is specifically for this application, a library that helps you do money-related calculations. There's Shatsian, there's Vercel things, and then we have some skills that help us build on Vercel. That's mainly the Vercel plugin with all the skills around React and also Vercel in general. And then Caveman, which help you not spending as much tokens because it's making your AI talk like a caveman. Basically, it removes unnecessary words and conjugations even just to make you use less tokens, and it actually works. The output is still the same, but you just use less tokens. So that's the first layer, skills. Then onto the context, most of that lives in the docs folder, but it starts out here actually in agents and cloud.md. They're both the same file, they're symlinked to each other until we have a convention. And what does that look like? Do I have the preview button here? Yes, this one. Okay. No, I can't see it anymore. Just going to close this again. Dat is misschien gemakkelijker. Met die slides in. Better. Right. What's in there, like Maarten explained, is basically a map. It tells AI where to go looking for things, and it's not the full rule set. So it will outline where to find architecture. That's a separate document. I'll get into that later. It'll find the docs specific to the product, the design, reliability, security, and the references. So the references will be about how we use libraries. Then some commands, and then some basic rules. They're mostly common sense things, but no new dependencies without humans' approval, things like that, that I don't want the agent to go out and do on its own, those are included here. It also includes, for example, our quality gates to be run at the end of every implementation. This is also caught by the pre-commit hook. If you let your agent commit itself, its code itself, but in case you don't, you can use this. Yeah, was the question.
Do you increase the character size or the font size?
Yeah, good question. I'm going to ask Maarten to do that. I was a Linux guy, and now I'm on Mac, and I'm still not used to it.
No.
Thanks.
Yeah, better. Right, but the actual text isn't that important. So these are just some common sense rules. This one is one of the important files. And there are some rules in here, like try to keep components under 250 lines. That's quite arbitrary, but I'm still looking for the most optimal way to do components and to set this limit, but it works for us now. And then some description of the quality pass. I mentioned architecture. This is actually a very nice file to have. It outlines our stack. That's quite basic, but this one I find is very nice to have, the file structure. It just outlines where stuff should go, basically. So AI has a map to see where it should put things, and we don't have an enormous amount of files going everywhere. And it also tells AI where to find things, where last things were put. So that features are always structured in the same way. So that's basically quite a big setup. Where to put new things, it's set up specifically here again. And per feature also, so quite well documented. Then onto the docs folder, functional analysis is quite extensive. This was done by our designers. When they were doing the prototype, they were also thinking about how should these features work, what should be in them, what should each button do. And so for each page, basically, we have a full functional analysis that's checked into the code base that AI can reference to find what it should be building and what not to build. So that's very nice to have. We have references. As I mentioned, they contain how we use libraries. For example, the 10-stack query one will outline how to set up the query client with the query provider, but also how to do things like data fetching and how to do it in a client-side way and a server-side way. Optimistic updates are in there, so that's how we do things. Of course, AI can go out and fetch documentation, but this is kind of our pattern. Audit is just a leftover file. I'm going to start here with security. This is how we configure authentication, authorization, which roles there are, things like that to take into account. Reliability is how we should test and also what not to test, which is also nice to have, how to run tests, things like that. And then product and design. These are files that work closely together with the skill that Maarten mentioned called Impeccable. Impeccable is the design harness. And these files will tell it where to put design tokens, where everything goes, but also in this file, what the product is about, who its users are, what the user should be doing, what the product purpose is, the brand personality, some references and anti-references, also nice to have, so it knows what not to build. So that's mainly references. And then the last part before I get into spec it is this one, which is traditional engineering, I would call it. It's a pre-commit hook that just runs formatting, type checks, and then follow as a code-based intelligence. So that will pick up on that code, duplicated code, and that could duplicate code. something else that I forget now, and then runs the tests as well. I usually let my agents commit their code, so they run into the pre-commit hook, which will make them self-correct if they don't do something correctly. And then the last part of that check is GitHub Actions. So we have some workflows that will run in CI to check the code again. The pre-commit hook I just showed will only check for the affected files, so we'll only run tests for files that were affected, only run linting and formatting on files that you actually touched. The CI will run for the full code base again. So some actions to do again the same thing, linting, formatting, type checks, tests, and then the full build. And if that passes, then we do code-based intelligence, clean up some stuff. And only when those things pass, we actually make a PR. And this you can get back into your, or we should find a way to do it automatically, but if you use the GitHub CLI, it's quite easy to get these things back, the results of these actions back into your code base. And then something Maarten mentioned a lot that we rely on a lot is SpecIt. SpecIt is a framework that helps us do spec-driven development. It's built by 2 GitHub engineers. And everything starts out from a file they call constitution, which is the constitution of our application. And it basically takes in all of the context files we give it, the functional analysis, the dependencies we use, and it draws up a constitution that has all of the core principles that this application should adhere to. So in this case, it's, I think, more than 10 even. And that's all derived from the code base or input you give it when you build the constitution file. This constitution can be updated, but then it will be documented what was updated and why, and it will be versioned. And that gets taken into every spec you build as a quality gate where it checks all of the principles in the constitution to check if the spec is correct. And that works in this way. Maybe I can just show, I'll use this window. Don't know if you had it installed, Maarten, in this code base. So basically we do for a new feature, SpecIt specify, that's the first step. Then we'll specify what the feature is and what it should do and where the files are that it should use. It will most of the time just find them. And that will result in always the same predictable output structured like this. So all of the specs you'll see here in the specs folder will look quite the same. They will always have the spec file, which is the output of the specify skill. And that will have user stories, only non-technical stuff, just what the feature should do. You can review this, iterate on it, and then you go to the next step, which is the plan step, which will detail a more technical plan together with the data model it should use, any contracts that should be in here, the quick start and the research it did. And the things I like a lot about the specs, for example, is it will always tell you what the user stories are, but also the functional requirements, what the key entities are it will touch, and assumptions, which is very nice to have. You'll always see what it's assuming is true, so you can correct it. And then dependencies, and it's not in this spec, but edge cases will also be there if there are any, which is very nice to have. Then you go to the technical plan, and if you have that and you iterated on it, you're fine with the plan. You'll, by the way, see, if I preview, that it will always check where to put things and add things in phases. And this is the last step, and I have too many files open now. So the last thing is basically it will list out tasks divided up in the phases, and then the magic is to just do the last step, which is SpecIt implement, and it will just go task by task, doing all of those things in just the way you wanted it because you reviewed the spec and built it. And this is checked into your code base. We check it into the Git repository and can be read by developers and by agents equally. It can be used as a reference. It will add a lot of context to your code base. You can always find why it did something, when it did something, and what it exactly did. And that gives you a very good frame of reference to build features on. So that are the most important parts of what I wanted to show and how we work now. So basically we are most of the time reading stuff and correcting it. And the final step is pressing implement, and then we review the PR, so that's reading again. So the development is switching a lot from actually coding to reading, redefining architecture, and making sure it's doing the right things in the right way instead of actually typing code. So, wow, that's mainly it. Any questions right now or later? Yes.
Just a quick one. Like, how do you prevent like the context switching fatigue that sometimes we may have?
That's a good question.
Like the 10 minutes because you're waiting for the agent, you know?
Yeah, depends on my day most of the time. Sometimes I just go do something else, like eat or go outside, have a coffee. Sometimes I just start the next spec in a new work tree. So yeah, I don't know how other people deal with context switching fatigue. Anyone has trips or ticks? You know what I mean for that? I also do feel that sometimes I'm more tired at the end of the day than I used to be. No, indeed.
Do you plan like any work in parallel when you're designing your specs? Because you mentioned that it goes task by task. Then you get to review until like...
Actually, SpecIt identifies parallel opportunities, but the default way is just sequentially. There is an extension that I am using now called SpecIt MACA, which stands for Multi-Agent Quality Assurance. That will dispatch multiple agents at the same time and also run a quality assurance pass afterwards. So that's what I'm using now as an extension built on SpecIt. So then indeed you can do things in parallel. I stopped doing multiple specs, multiple implementations in parallel because that just got confusing. Yes?
I'm wondering, like, these are all Markdown files. I've noticed that using HTML gives much richer visual presentation and makes it easier for me to understand what the agent means, and can give me mock-ups of UI or things like that.
Mm-hmm.
So I'm wondering how you look at that, or if you experiment.
I haven't
with it,
used HTML to do this, no.
Okay.
But I will try it now, yeah. No, the only visual addition, let's say, is I do use mermaid diagrams sometimes to visualize like database tables and things like that, flowcharts. But I haven't used HTML.
Yeah, there's this post of Andre Carpati who says like half of our brain is for visual processing.
Mm-hmm.
So the ideal way of communicating from a computer to the human is visually. And then Markdown is super limited.
That makes
and the
sense.
other way around, from humans to computers, it's voice. It's fast and free.
Yeah, I've also seen people use voice a lot, yeah.
I do know in the team people use superpowers as well.
Mm.
Superpowers has a visualize skill. I've used it in the past before, and I don't really code anymore.
What kind of skill?
It can visualize what it's trying to tell you. So it basically turns the proposed markdown or the markdown that it outputted, it turns it into a visual representation in HTML. I've used that in the past, and I think some people in the team also use it to get a visual understanding of what the markdown is trying to tell you.
How do you feel about that?
It's part of the superpowers skills library. It's a plugin with several skills, and one of them has a visualize.
Okay. Yeah, in the back.
A very practical one. This is for specs, which is probably for new stuff, but do you align it with like bugs? I prefer that like the same process, and we try to do the same process. Are the bugs then, when you decide if big one is a spec? Because you seem to have a different process. that something that you're thinking about? And the other one is indeed, like even here, what I noticed is, we ditched our IDE, basically fully, but we spend a lot of time with using UX design. And in Specate, one of the things I'm missing is indeed not the design in terms of, that's all basically. The UX, basically, asking Claude or Codex to come up with different variants of because the interaction is most of the time we actually spend more time on the parts of those questions.
Yep. The second one, we, for a lot of projects, still work with designers. So in this case, for example, the prototype was built by our designers. Sebastian and Mathieu are also here. They build a lot of design in code right now. So they are designing by prompting Cursor and Claude. That gets turned in by also having the agent harness into code that is so React components, basically. Code that is up to our standards most of the time. And that's the step we use then to actually code on. So the specs you see here are built taking the prototyped code into account already. And then after implementing the spec, we do run an audit pass of Impeccable, the design skill I mentioned, which will then check for inconsistencies in the design, check if things like tokens were used correctly, and then also add accessibility features. But yeah, design gets done mostly by the designers, and you can ask them how they work. I think it's a combination of Claude design and Cursor and other tools. But they
a lot of screenshots of existing tools and things I don't understand.
Yes, that's different. We've thrown all, thrown it together, so I understand that.
Yeah. And what was the first question again? Sorry.
Aligning the, I think you have this is specs, new functionality, this big one, but you have like the little change request, the bugs.
Yeah.
It seems to be that you have different flow here.
Good question. We're also indeed thinking about how we best do this. It's for some minor bugs, it's a little bit overkill to have it do all of these things and output a lot of these things. Although the upside is that you can very easily trace what it has done and why, but it will also probably get you better results because of the steps. But for minor things, it's usually overkill as well, and you could get around with just doing Claude's plan mode, for example, or just try to one-shot it. We're still in the process of figuring out what the best way of doing that is.
One of the things we are currently experimenting with is basically, because for some of the specs, it's way too verbose. So basically, you have an initial step that makes where the AI do an estimate of the complexity, and depending on the complexity, we ask it to write from a very verbose one to very, very, very simple ones, and like that, we try to follow it.
Yeah, that might make sense. In terms of verboseness, I've been reading these a lot, and I've also tried to compress them sometimes with the caveman skill, for example. That's very good at reducing documents. Most of the time, the output of that is that every letter is useful. So the spec kit is really a good approach to doing things, I find. A lot of almost everything that's in there is actually relevant. Afron? We can ask some more questions afterwards at the bar or in the question Q&A afterwards. Well, I'll give the word to next guys. Yep.
I'm going to quickly go through this because it's time for Jonathan for his talk. The things we still struggle with, I mentioned it before, we still use Notion quite a lot as our human interface for documentation, but we need to keep it in sync with all of the documentation, especially functional analysis in the code base. Currently, it's still keeping track of the Git changes and making sure that everything is represented in Notion. We're working on an automated synchronization with the Markdown API from Notion to make sure that everything always is up to date in two places. We have an adoption curve as well internally. I've mentioned it before. You have power users doing more advanced setups, working with multiple agents in parallel, building custom agents. But the main workflow, I guess, is still quite Cloud Code in front of you, cursor in front of you, and starting off an implementation with SpecKit, for example. Biggest thing is you delegate the typing, not the thinking. The thinking is still something we need to do and make sure that it's as we want it to be. Have it take our taste and skills and make sure that it's implemented that way. Can be very expensive if you make mistakes. I'm sure all of you ran into some sort of expensive mistake. For us, the one was the surprise $800 bill per month for a single project because every commit went through a very deep technical AI review. That's not needed on every commit. You can do it in just at the PR, for example. So that was an expensive mistake on our side. Without a frame, that's basically the vibe coding part. Faster is definitely not better. So this basically represents 15% more feature branches, 15% more output, let's say. But it also reduced the success rate on the main branch in terms of testing, successful testing runs with about 7%. So it's a trade-off between going really fast without as much structure and documentation and making sure that everything's reliable on the main branch. Loop engineering, not going to go too much into detail, but that all builds on top of this. You need to have a proper harness, you need to have a proper structure in place, and then you can start automating loops like having bugs that come in through any channel, can be Slack, WhatsApp, email, whatever it is, Sentry, and automatically kick off the bug fixing loop, for example. Same for support tickets, same for feature requests, whatever it is. But make sure that the harness, the underlying structure is in place. Maybe one thing is the harness, it doesn't really shrink. A lot of people talk about a minimal harness, etc. But a lot of what the harness entails gets absorbed by the model. It's still limited, but you can see the shift from basically only having bash and tool calls to planning and verification, and now you also have the long horizon memory, etc. So part of what we call a harness is constantly shifting, evolving, and getting absorbed by the model as well. 3 challenges we still have today is moving from local running agent and harness to full cloud sandboxes. We have parts of the things we do that already run in a cloud sandbox. For example, we kick off linear Cloud Code agents quite a lot. They run in sandboxes, but you need to make sure that they have access to everything. They need to self-correct. For us, a pretty important one, I guess less important for you, although I did hear something about complexity and estimation. So for us, it's important to get a measure of how expensive a feature will be. The implementation of a certain deliverable will be. That's also something we're still figuring out. How do we do cost attribution to a single agentic run for a feature, for example? Similar to how the cost of a feature could be attributed to a team running for 5 sprints, for example. That's something we're still figuring out. And then if you have the cloud sandboxes running, there are new challenges if you do a lot of them in parallel. And the main challenge is how do you let the agents communicate? So that's where you get into orchestrator territory, some sort of a persistent file system that's outside of Git where agents can communicate with each other. That's also something we're still figuring out how to do that. And that's about it. So I want to leave you with this. And I think that's the perfect segue to Jonathan.